Hi, I want to explain about our group project. Okay, so first, this is our 1-bit 4-to-1 multiplexer, and we use by using basic gate. And this is the waveform simulation for the 1-bit 4-to-1 multiplexer, and we can see that when the selector equals to 0, 0, we select the first input, which is I0, and I0 is 1, so the output we also get 1. And next, this is the 4-bit 4-to-1 multiplexer. We combine 4 4-to-1 multiplexer, and this is the waveform simulation for the 4-bit 4-to-1 multiplexer. And we can see that the selector equals to 0, 0. We select the first input A0, which is 1, 0, 1, 0, and the output also 1, 0, 1, 0. And the next is the full adder using basic gate. And this is the waveform simulation result for the full adder. We can see that it is functioned correctly. And this is, we use 4 full adder to combine to become a 4-bit adder and subtractor. It can change between the 4-bit adder and subtractor, and this is the waveform simulation result for the 4-bit adder and subtractor. And we can see that when A is 1, 0, 1, 0 and ALU OP is 0, and we had the inverter in here, so invert the 0 become 1, so it is a 4-bit subtractor, which means that A minus B, and B is 0, 1, 1, 1. We can convert to 2 complement and add with A, and we get the carry output is 1, which means that is positive, and this is the final result, 0, 0, 1, 1. And next, this is the 1-bit D flip-flop. This is the waveform simulation result. We can see that it also functioned correctly. This is the 4-bit D flip-flop, which we combine 4 D flip-flop in here. And last, this is the waveform simulation result for the 4-bit D flip-flop. And we can see that the initial state is 0, 0 because the clock haven't rise yet, and when the clock rise, it become 0, 1, 1, 0. After that, finally we combine all those things to become ALU, and we have 2 4-bit 4-to-1 multiplexer and 1 4-bit full adder and 1 4-bit D flip-flop, and this is the output. And now we try to run it. We already insert the random value of the input, and we run the simulation. Okay, we can see it functioned correctly. When A selector becomes 0, 0, we select the A0, 1, 0, 1, 0, and B selector 1, 0, select the third one, which is 0, 0, 1, 1, and ALU OP is 1, invert becomes 0, so it's a adder, so we add 1, 0, 1, 0 and 0, 0, 1, 1, and so we can see that the output is 0, 0 at initial state because the clock haven't rise yet, and when it rise, it become 1, 1, 0, 1, 1, 0, 1. And that's all. Thank you.